part 2 of Introduction to Maya Fluids. Okay, so I'll go ahead and create a 3D container, and I'll create a blank container. Create 3D container. I'll also add a polygon object, prism in this case, and we'll emit from this object. So select container, select object, fluid effects, add edit contents, emit from object option box. Make sure that emitter type is surface. Let me increase my time range and play the simulation. Okay, now I want my fluid to fall down, so for that I can go to fluid shape, and under, let me close these, under content details, density, I'll set buoyancy to -1.5, so it will make the fluid to fall down. Okay, and I want a little bit bigger container, so I'll extend my container by going down to fluid effects, extend fluid, and I'll extend it by 10 units each in positive X and negative X direction. Apply and close, and I'll also edit my resolution. So just shut off this keep voxel square, and I'll crank this up to 60, 24, 20. Okay, and I'll move my object here, and again resim. Alright, so let's jump to that section where we left off in part 1, and it was surface. So by default we have volume render. Maya renders the fluid as a volumetric cloud, as you see here. Alright, you can set it to a surface render. Once you set it to surface render, you have two options: hard surface and soft surface. If you want the transparency of the object constant inside this container, then select hard surface, otherwise select soft surface. Okay, and the transparency in the hard surface is solely determined by the transparency attribute you will find under shading. Here we have transparency, and it controls the transparency of our hard surface. Okay, next we have surface threshold. This is the slider actually responsible for creating this. This value is responsible for creating the shape of this fluid. If you crank this up, you can see that it's directly affecting our shape of our fluid here. Okay, and then we have surface tolerance. It defines that how close points a sample for a surface lie on the exact surface threshold density. Okay, and this value is relative to the quality value here. So let me go ahead and quickly render this scene here and save it. Let's scroll down and find quality, shading quality. Let's crank this up to 3, and then we'll adjust the surface tolerance, and now you would be able to see the difference. Okay, so it's affecting our density values, the surface tolerance. A specular color controls the amount of light emitted from the regions of density due to self-illumination. So if I go ahead and give it some color, take a render, you see that hint of that green here. and you can bump that up further by lowering down this cosine value. If cosine value, if you decrease this value, you'll get tighter, highlights, tighter specular color highlights. Okay. Um, so let me shut off this specular color by changing it to black. Next, we have the environment, and this environment ramp defines a simple sky to ground environmental reflection for our fluid. So the left of the ramp represents the top of the sky, and right of the ramp represents the right of the bottom of the sky. Okay. So if I go ahead and give it some color, say some orange to light blue, and the last white. So now when we render, our fluid will reflect this environment color, and from here you can set the interpolation of the color values. This interpolation controls the way color blend between position on the ramp. So this is our position 0, this is position 0.496, and this is 1. So 0 is at the leftmost side of this ramp, and 1 is at the rightmost side. You can go ahead and click on this button, and it will open up this bigger gradient editor for you, from where you can set the interpolation, colors, and position as well. If interpolation is set to none, then there will be no interpolation between the colors, and each color is distinct here. If it is set to none, if it's set to linear, then values will be interpolated with a linear curve and RGB color space. If you set it to smooth, it's gonna set the values are interpolated along a bell curve. Okay, in the shape of the bell. And if it is spline, then the values are interpolated with a spline curve. And what it does, that it takes the neighboring position markers into account for a smoother transition. Okay, so you have that option there, and refractive index control the refractive index of our environment. So if I go ahead and render, you can see that that color will be reflected in this fluid. So linear, and just render this out. Okay. The next option we have is output mesh, and output mesh attributes allow you to control the resolution, smoothness, and speed of the fluid when you convert fluids to a polygon. Okay, so if it is to the default resolution and you go to modify, convert fluids to polygon, you'd be able to see the mesh here. And now you can apply any shader to this and render this out. Okay, if you want to increase the res, if you want to make this high res, just bump up the higher resolution value and then convert. Then go to modify, convert fluids to polygon, you'll have the denser mesh. So you have that option there. Let me set it back to 2. Color per vertex, and do this. System is little slow because of the high res geometry here. Okay, so color per vertex generates color per vertex data for you, and opacity per vertex and incandescence per vertex data is stored when you convert in a color set, and that you can use with mental ray vertex color texture options. Likewise, you can store velocity per vertex data, and then later use this data to give your fluid motion blur. You can also save UVW per vertex data that lets you map a texture to the surface of your output mesh. And the last option here we have is use gradient normals, and you can turn this option. You can turn this on to make the normals on a fluid output mesh smoother. So when it is on, user normals are created for the output mesh, and then you can use it for your texturing purposes. Okay. Next option we have here is shading, and first option is transparency, so it controls the transparency of the fluid. Next we have glow intensity, and it's a post process. It affects the fluid after the rendering. At the end of the rendering, it affects, and it gives it gives the fluid a nice glow. Then we have drop off shape. It defines the shape uh, to to use to define an outer boundary for creating a soft edge fluid. So you can control. Okay, so we have here sphere, cube. We have different options here to control the drop off shape of our of our fluid. So you have plenty of options there. Let me set it back to cube. It's a little slow. So let's set back to cube, and then the edge is defined by this edge drop off parameter. Okay. Next is color. Okay. Next is color. This color ramp defines a range of color value used to render the fluid. Okay, so you can set the range, say red. We have one more at the center, and we'll make it yellow, and at the end let's make it blue. Okay, you'll see here that the color is blue. It's not picking the color from the ramp. Okay, but it's not true because our color input is constant. So we can set this to X gradient. So now you can see that the left of our fluid color, the left of the container edge um, is colored as blue, and then we have this yellow and then red. Okay, we can set it to Y gradient. You can see there. You can set it to G gradient. You have plenty of options. Center gradient. You can set to density, temperature, speed of the fluid. You can set it to density and fuel. So let's go ahead and set it to Y gradient for the moment. And this input bias, you'll see it everywhere in Maya fluids. This input bias controls the sensitivity of the selected color input. If it is set to 0, then it will map exactly at the center of the fluid, this color. I mean, if it is 0, 0. Okay, so if input bias value is 0, 0, then color input value of 0.5 maps to the exact middle of say if set it to 0.5, it maps exact middle of the color ramp. Okay, so this value ranges from -1, where you have -1 is this side, +1 is this side, so you can animate this to give your fluid interesting effects. Okay, this is input bias. Next we have incandescence, and for that I'll go ahead and just delete my current objects, and I'll create a new 2D ramp with container. Okay, and for this incandescence to work, I'll go ahead and turn on my temperature grid to dynamic grid, and let's play. Now if you render, you'd be able to see that now we have this incandescence going on here. Okay, and you can define the colors here. So this incandescence controls the amount and color of the light emitted from the region of density due to self-illumination. Okay, and this illumination that this incandescence produces does not get affected by illumination or shadowing. Okay, again you have interpolation type here. You can set the incandescence input. You have plenty of options there. Okay, right now it's Y gradient, and if you go ahead and turn your fuel grid as well to dynamic grid, then you would be able to see the fuel values as well. Okay, so it's pretty powerful. Incandescence. Next is opacity. Opacity, controls the the opacity of your fluid, so you can make your own curves here to make your object less transparent or make it opaque. Okay, you can use this interpolation. You can modify this curve. You can click on this button and then um, adjust your points in this gradient editor. Okay, and density, you can also control the opacity input using X gradient, Y gradient, or density, the default one. Then you have option for input bias. One is totally opaque grid, and 0 is the default value. -1 will remove everything from the will make it completely transparent. Okay, next is matte opacity, and it controls how fluid show up in the matte in the alpha channel. Okay, so we have different options here. We have opacity gain, the default one. You can reduce this opacity, and it will affect your alpha channel. Now you can say it's pretty dim here. Okay, you have option for solid matte. It will create a solid matte for you, and you also have option for black hole. And a black hole, in black hole, the matte opacity value is ignored, and all the matte for this fluid is set to transparent, so you'll get complete black hole here. So you have options for the controlling the alpha channel of the render, of the fluid render. Then we have shading quality. It controls the samples per ray used in the render, and as you crank this up, you get better results with your rendering, but it's gonna take some time. Okay, you have contrast tolerance. um, it defines the maximum contrast in the effective transparency of a volume, so you have that option there to control the contrast. You have sample method. If you want to uh, you know it controls how the fluid is sampled during rendering, and the jitter avoids bending artifacts but sometimes add noise to the final image. Okay, so you have to set the quality to high to get rid of that. And then we have render interpolator. We have linear as smooth. Okay, so it select the interpolation algorithm to use when retrieving values from the fractional points within a fluid voxels. Okay, and it is used when you texture it or when you shade it, and then it gives you, the smooth gives you better quality, but linear is fast to calculate. So you have two algorithms there. Okay, to calculate the to retrieve the fractional points within a fluid voxel. So that is shading quality for you. So now let's talk about the built-in textures. So I'll go ahead and create a 3D container. Reset the size, and I'll set the size to 20, 1, and 20, and I also change the resolution to 40 for rather 80, 84, and 80. So it will give me a nice dense container here. Okay, now open attribute editor, select fluid shape, and under textures we have texture color, texture incandescence, and texture opacity. So you can turn these options on to apply the current texture to the color input value, or the incandescence input value, or the texture opacity input value. So what we'll do here, we'll turn on texture opacity, scroll up and find out opacity under shading, set opacity to Y gradient, and immediately you'll see this pattern here. Let me turn off the grid. Now I'll adjust this opacity graph to get a nice pattern. Okay, let's take a quick render. So this is what we get right now. So here we have texture type. Default one is Perlin noise, and it's a standard 3D noise as used in the solid fractal. Fractal. Okay, this is the same pattern. We select fluid shape again, textures. Next type is below, and use below texture type to create puffy cloud-like effect, like here, as you can see here. Okay, but it's computationally intensive and therefore slow, the below texture type. Next we have volume wave, and it creates a sum of 3D waves in a space, so you can use that as well. Wispy is Berlin noise, but that uses a second noise as a smear map, so you get a smearing like effect. Okay, the last one is space time, and it's also like Berlin noise, but it's 4-dimensional, and the time is the 4 dimension. Okay, next we have coordinate. Let me change it to Berlin noise. Next we have coordinate method. Default is fixed, and it sets the value to equal to the object space coordinate system 0 to 1 for this container in X, Y, and G. Okay, if you set it to grid, then Maya will use a grid of points and interpolates to define in between values. Okay, and these the coordinate value moved using the density solver, and the speed is controlled through this coordinate speed. Okay, color texture gain, incandescent texture gain, and opacity texture gain. We have 3 sliders here, and right now we have enabled texture opacity. That's why I'm getting only opacity texture gain. um, Opacity texture gain determines how much the texture affects the opacity input value, so you can crank this up or down. Okay, next is threshold, and it's the number added to the whole fractal. So if you crank this value up, it will make whole fractal uniformly brighter. Okay, and if some part of the fractal are pushed out of the range that is greater than 1, then they are clipped to 1. Okay, so this is what threshold does. Amplitude is a scaling factor applied to all the values in the texture. Okay, and it is centered around the texture's average value. So if you increase the amplitude, light areas get lighter and darker areas get darker. Okay, and next is ratio, and it controls the frequency of the texture or a fractal noise. Okay, so if you want to increase the fineness in your pattern, in your texture, then you can crank this up, the ratio. Okay, next we have frequency ratio, and it determines the relative spatial scale of the noise frequency. So you can also use this to to get different patterns. Next is depth max, and depth max is used to control the maximum amount of calculation for the texture. Okay, invert texture, turn invert texture on. If you turn this on, it reverses the range of the texture. All right, Inflection, if you want to, uh, if you want to generate a puffy or bumpy effects in your pattern, then you turn on this inflection. It will give you that effect. Texture time can be used to animate the texture. You can also write in an expression. This middle mouse drag this here and type in equals time. Click on create and close, and as you play your uh, as you play your timeline, your texture will get animated. Okay, so let me delete the expression. Frequency um, is the fundamental frequency of the noise. Okay, so as you increase the noise value, it becomes more detailed. Okay, texture scale is the scale of the noise in the local XYZ axis. You can change that as well. You can change the texture's origin. Okay, so let me set back to default values. Texture rotate is a new addition to myt 2011, and it sets the XYZ rotation values of the fluid's built-in texture. X rotation, Y rotation, and G rotation. You have that control there. Okay. Next we have implode, and it warps the noise function in a concentric fashion. It pulls it pulls everything towards the center, or it pushes away from that center. So right now implode center is 0 0. So if I set it to 0 or 1, I get this effect. And of course I can change my implode center. Alright. Next we have below density, and it will be only available if we set our texture type to below. Okay, so below density controls how many cells are there, how many cells are embedded in this medium. It's controlled by below density. Spottiness controls the randomization of the density. Okay, size randomness controls the randomization of the size. If this value is 0, individual blobs used by this texture will be of same size. Okay, that is size randomness. And this randomness, next parameter randomness, controls how the cells for the below noise type are arranged relative to the one and other. So if it is 1, then you'll get complete randomization. If you set it to close to 0, you'll get this regular pattern here. Okay, next is fall off. It controls the way intensity falls off for the individual blobs. So you can set it to linear, smooth, fast, and bubble. Okay, so this is about the built-in texture node.